Football, America's favorite sport, mainly because it has violence, gross food, and a good atmosphere. But what does football have to do with physics? Let's find out with an example. Here we have Jeff. He likes to play football. If his mass is 100 kilograms and his acceleration is 10 meters per second squared, what is his force? We can figure this out with the formula F equals ma. To figure out that his force is 1,000 what? We have to have a unit. The unit for force is, of course, newtons. Now let's talk about gravity. As Jeff throws the ball through the air, gravity is affecting at 9.8 meters per second squared. This means that if we drop it from a building, at the first second, its speed will be 9.8 meters per second. And at the second second, the speed will be 19.6 meters per second and continue. Now let's talk about air resistance. As the ball flies through the air, air is pushing up on it, causing friction and causing it to slow down. What's causing it to slow down is oxygen atoms in the air. The more oxygen atoms in the air, the slower it goes, the more friction. Now let's talk about Newton's laws. His first law states that a body at rest must stay at rest unless acted upon by an unbalanced force. This means that as Jeff kicks the ball through the air, the unbalanced force is air resistance, gravity, and the net behind the field goal. So as he kicks it, of course, it'll eventually slow down and stop. Now let's talk about Newton's second law. Acceleration occurs when a force acts upon a mass. This means that if Jeff approaches the beanbag with 1,000 newtons of force, and the beanbag, we can figure out, only generates 0 newtons of force, we can determine that Jeff will be able to accelerate the beanbag. Now let's talk about Newton's third law. Every action has an equal and opposite reaction. This means that if Jeff approaches the bag at 10 meters per second, generating 1,000 newtons of force, he will push 1,000 newtons on the bag, and the bag will push 1,000 newtons back on him. Now let's talk about potential and kinetic energy. Jeff and the ball both have potential energy. When he throws the ball, this energy becomes kinetic. But what exactly is potential and kinetic energy? Well, kinetic energy is defined as the energy of motion. A ball dropping, a train moving, and a human running. Potential energy is defined as stored energy, a spring, a ball at the top of a hill, and humans. That's the end. Thanks for watching.